All right, good morning and welcome to Master Talker online class. In today's video, we'll be talking about current electricity. All right, so right for me, electric current is defined as the quantity of charge flowing per unit time. All right, so mathematically, we talk that what current is equal to what charge. Current is equal to charge per unit time. That is charge over time. So current or electric current, but let me just write current. Current is equal to what? Charge is equal to charge over what? Over time. And we represent current as what? I. And represent charge as what? Q over what? T. So we have that Q is equal to IT. This formula is very, very important. Q is equal to IT. Right? So the next note, current electricity is measured in ampere. Right? And using an what instrument called ammeter. The instrument used in measuring current is what? Ammeter. But don't forget that charge is measured in coulomb, while this one is measured in what? In second. So another way you can measure current is what? Is coulomb per sec, or you say what? That is measured in ampere. All right. But the SI unit, the standard one, is what? Ampere. Okay. So the next thing we'll talk about is the potential difference. Potential difference. Potential difference V. Right? So right for me, the potential difference between 2 points is defined as the work done in moving a unit positive charge from one point to another. Right? The work done in moving a unit positive charge from one point to another. So you should know that potential difference is equal to what? Work done over what? Over charge. Very important. Work done per unit charge. So potential difference is V is equal to what? The work done all over what? All over charge. Right? And potential difference is measured in what? Either joule per coulomb. Joule per coulomb, or you say what? That is measured in volt. But the unit, the SI unit is what? Is volt. All right? So right for me, note the total work done or energy in moving a unit positive charge around a complete electric circuit is the electromotive force. Okay, that is the EMF. Okay, is also the volt of an open circuit. So the volt of an open circuit is called the EMF. Okay, so the main thing we will look at now is what is called the Ohm's law. The Ohm's law, OHMS, the Ohm's law. Now, Ohm's law stated that the current that passes through a wire or conductor is directly proportional to the potential difference across its end, provided that temperature remains constant. All right. So current is directly proportional to what? Potential difference. All right. So we now have that what? Or you can say that what? Okay, let me start from the potential difference across. The potential difference is directly proportional to the what? To the current. Is the same thing. So if you remove proportionality sign, you bring in a constant. So V is equal to what? IR, where R is your resistance, which is the what? Your constant there. Okay. So we say that what? That V is equal to the potential difference. Potential difference measured in volts. Okay. Where I is what? The current measured in ampere, and then your R is your resistance. R is equal to what? The resistance measured in ohms. And ohms, the symbol of ohms is like this. Okay, it's measured in ohms. So note, materials that obey Ohm's law are generally called ohmic conductor. Right? Example includes metallic conductor or wire. Right? In contrast, materials that do not obey Ohm's law are generally called non-ohmic conductor. Example include diode, electrolyte, and what? Transistors, right? etc. The complete path through which electric current flows is called the electric circuit, right? It is a network of a set of electric conductors linked up so that an electric current can pass through all of them from a source of electricity, either battery or and back to the source. So the next we'll talk about is what? Electric cell. Electric cell. And then the arrangement of electric cell. Electric cell. So, right, these are the device that generates power. That is, example of it is what? Battery is a good example of electric cell. Battery. Okay. So the first thing we'll talk about is what? Let's talk about the arrangement of electric cell. Arrangement of electric cell. Arrangement of cells. Okay. The first one we have series arrangement. Arrangement of cells in series. That is series arrangement. Series arrangement. So now if you have this cell like this arranged in series, okay. Now, how do you know a cell? We know a cell by the long one and the short one. The long one is the positive charge. The short one is the negative charge. Positive, negative, positive, negative. That is how we know a cell. And we have that they have the potential difference across them. The potential difference across them. Okay. So please, there is something I need you to know for me for a cell. In fact, any arrangement, as far as electricity is involved, any arrangement at all, just know this word for me: P to P. P to P. What's the meaning of P to P? P to P means that what? That the potential difference across a parallel circuit or parallel arrangement are the same. Okay? Just know P to P. P to P means what? The potential difference across parallel arrangement are the same. So, but this one, they are not the same. So we said that what? The total voltage here should be what? V1 plus V2 plus what? V3. So let me call this V1, V2, V3. All right. So that is that. Why? Because they are in series. But what about the one in parallel? But the one in parallel, let's talk about the one in parallel. Number 2, parallel arrangement. Parallel arrangement. For parallel arrangement, let me have something like this. Let me have this one is like this. This one is like this. This one is like this. So they are all arranged in parallel. How do you know parallel arrangement? We know them because they are not being connected by a straight line. Look at this one. If I'm moving this way, I jam this one. I'm still moving on a straight line, jam this one. On a straight line, jam this one. But this one, if you're moving on a straight line, you are jamming just one. So they are being connected by different this. So this is positive, negative, positive, negative, positive, negative. So I have my V1, V2, and my V3. Okay. Now, I told you P to P. What does it mean? It means that what? The potential difference across parallel arrangements are the same. So what do I have? That V, the total V I'm looking for should be V1 must be equal to V2 and it must be equal to V3. So in parallel arrangement, the potential difference across a parallel arrangement are the same. So that is P to P. For any parallel arrangement, the potential difference are the same. So the next thing we'll talk about is the resistance or the resistor. So let's talk about resistor and its arrangement. So resistor now, for resistors, I hope you know that a resistor is a device that opposes current. It does not allow the flow of current, right? So let's talk about resistance. Resistance in series. Resistor arrangement. Arrangement of resistors. So the first one we'll talk about is resistors in series. Resistors in series. Now, let me have this. This is the first resistor. This is where our resistor is. Let me call it R1. The second resistor, R2. And then the third resistor, R3. All right. They are being connected to a battery. So let me connect them to a battery. Okay. So this is my positive and my negative. Now, when you have resistors that are arranged in parallel in series like this, all right, don't forget what I said. Don't forget what I said that, in fact, this formula is very important. V is equal to IR. It's very important. So now I'm talking about this now. So what I consider is either current or voltage, and I said P to P. What's the meaning of P to P? That in parallel arrangement, that the potential difference are the same. So the one that are not the same is what you use in deriving your formula. Okay, so since the potential difference across parallel are the same, so the potential difference across series are not the same. So I know that I will have that V1 will pass through this one, V2, V3. They are not the same. So since they are not the same, that is what I will use in deriving my formula. I will say that what V total will now be V1 plus V2 plus what V3. I know my formula that said that V is equal to IR. So if I now put it here, I will now have that V. So now, since we concluded that what, that the potential difference in series are not the same, then the current in series should be the same. All right, so that is how they are. If this one is the same, this one will not be the same. But if this one is the same, this one will not be the same. So I will now have that what, I will now have that what, I1, this one is the total. Okay, let me call it, the total should be what, IR for the total. Let me call it total. Okay, in fact, this one is total. Is equal to I1 R1 plus I2 R2 plus I3 R3. Very simple. Now, but note that I1 is equal to I2, and which is equal to I3. So let me say that all of them are just equal to I total. So anywhere I see I1, I'll put I total. Anywhere I see I2, I'll put I total. Anywhere I see I3, I'll put I total. So I have that what? I total R total, okay, is equal to what? I total R1 plus I total R2 plus I total R3. All right, very, very simple. No, now if you note, you see that they have I total in common. So I'll have that what? I total R total is equal to R1 plus R2 plus R3 plus R3. All of them has I total in common. So if I total now cancel I total, I will now have that what? My R total is equal to R1 plus R2 plus R3. Okay? So now, anytime you want to find the equivalent resistance or the total resistance, okay, in series, you just have to add them. You just have to add them, and that's all. Nothing else. You just have to add them. So let's talk about the one in parallel. For the one in parallel, let me draw it. I have something like this. 1, 2, 3. So I have the first resistor. Let me say this is R3, R2, R1, and they are all connected in parallel. Then to a battery. All right. Now, I have that V1. I have that V. In fact, it's not only, you have the current that passes here is I1, I2, I3. All right. So the same thing is applicable here. So I have my, permit me to cut this one like this. I have my V1, V2, V3, I1, I2, and I3. Okay. Now, don't forget your P to P. P to P means that what? That the potential, that the parallel arrangement, the potential difference V is what? Is the same across the three of them. So, and I told you to derive your formula, you should go with the one that is not the same. So if you remember that V is equal to IR, since the potential difference V is the same, so the current is not the same. So I'll tell them that what? That the current total is equal to what? The first current plus the second current plus the third current. Okay, very simple. I know that my V is equal to IR. So if I make I subject of formula, it implies that what? My R will now be what? V over what? R. So anyway I see I'll put V over R. So I have that V total over R total is equal to what? V1 over R1 plus V2 over R2 plus what? V3 over what? R3. But don't forget that your V1 is equal to V2 and is equal to V3. which is equal to my V total, because I told you that in parallel arrangement that the potential difference are the same. So it will now give me that what? V total over R total is equal to V1 over V total over R1 plus V total over R2 plus V total over what? R3. Okay. Now, if you now see that they have V total in common, okay, permit me to clean here. So they have V total in common. Since they have V total in common, I'll be having that what? V total over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And they all have V total in common. So V total cancel V total. I have that 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. All right. So now this is the formula to get what? The total resistance. The total resistance in what? In parallel arrangement. The total resistance in parallel arrangement. All right. Okay. So, or you call it the equivalent resistance in parallel arrangement. Okay. So now let's solve some question to illustrate what we have just done. Okay, let's solve some question to illustrate that. Okay, the first question we're going to solve said number 1, question time, blessing time. They say calculate the magnitude of the charge, flowing through a conductor, for 3 hours when the current in it is 100 ampere. Okay, the current in it is 100 ampere and they asked to find the charge. So solution, I know that Q is equal to what? IT. Q is equal to IT. So what they say we should find? The charge. So my Q will now be what? They gave me my current to be 100 ampere and they gave me my time as 3 hours. And 3 hours is 3 times 60 times 60 to keep it in second. So what do you have? 3 times 60 times 60. 3 times 60 times 60. So I have what? I have 108,00 seconds. So I now have the what? My current is 100 times 108,00. So I have 108,0000 coulomb. Okay? So that is that. So question number 2. Question number 2 says okay? 1 minute. So question number 2. Where is question number 2? Question number 2 say calculate the current. Calculate the amount of current. Calculate the amount of current flowing through a metallic conductor for 20 seconds if the quantity of charge in it is 120 coulomb. Solution. So what do you do? They've given us everything we need. We know that what charge is equal to IT. Q is equal to IT. So what do you have if you know that Q is equal to IT? So you now have that permit me to refill my marker. So I have that Q is equal to IT. So let me get everything they gave me. They gave me my Q, which is what? 120 coulomb. They gave me my time, which is 20 sec. Okay, I know that my Q is equal to IT. So my I will now be what? Q over T, which is what? 120 divided by 20, which is what? 6 ampere. Very simple. Okay, so the next question, so question number 4, question number 3 rather. Question number 3 say calculate the work done in moving a charge of 250 coulomb through a potential difference of 60 volts connected across the ends of the wire. Okay, solution very simple. They gave me my potential difference V is equal to what? 60 volts, and they gave me my charge is equal to what? 250 coulomb. I know that potential difference is equal to what? Charge per unit sorry, potential difference is what? uh Potential difference is equal to what? Work done per unit charge. What am I saying? Potential difference is what? The work done per unit what? Charge. So potential difference 60 is equal to work done over what? 250. So my work done is equal to what? 60 times 250. So what do you have? 60 times 250 will give you 1500 joules. Okay, because work done is measured in joules. All right, so the next question, question number 4. Question number 4 said a work of 30 joules is done in transferring 5 MC, that is millifarad of charge from a point B to a point C in an electric field. Now what is the potential difference between B and C? Solution. Okay, solution, we tell them that the charge they gave me is what? 5 MC, and that M means times 10 raised to power minus 3. So 5 times 10 raised to power minus 3 C, and they gave me that the work done is equal to what? 30 joules. And I know that my potential difference is equal to what? Work done per unit charge, which is what? Work done is what? 30 divided by 5 times 10 raised to power minus 3. So what do you have? 30 divided by, you have 6,000 volts. 6,000 volts. Okay, very, very simple. Question number 5. Question number 5. You know, we start from the small question, then we move to more difficult question. Question number 5 says 2 ohms and 3 ohms, okay, resistors are connected in series across a 60 volt. Calculate the I total resistance II current through the circuit. III is to calculate current in each resistor. IV, the potential difference in each resistor. Okay, solution. Now, don't forget, whenever you hear that something is in either series or parallel, the first thing that should come to your mind is P to P. And what's the meaning of P to P? That parallel arrangement, that the potential difference are the same. So since it is a series arrangement, the potential difference are not the same, but the charge must be the same. So what's the first thing to get? You get your resultant resistance, or the total resistance. and the total resistance for series is just R1 plus R2. So which is what? 2 plus 3, which is what? 5 ohms. All right. And they gave me that the potential difference across it. So this is the total potential difference, which is what? 60 volts. And I know that V is equal to what? IR. So I total will now be what? V total over R total, which is what? V total is 60 divided by R total 5. So you have what? 60 divided by 5 will give you what? Problem, I think is 12. Where is my calculator? 60 divided by 5 is 12. Okay, yes, 12. Okay, so I have 12 ampere. 12 ampere. So this is the current that passes through all of them. Okay, that passes through everything. So the now said thou should I. So this is my I, and then this is my I. So my I said the current that passes through each of the resistance. We'll tell them that what? Let I1 and be the current that passes through the first one, and then I2 be the current that passes through the second one. So you now have that I1 must be equal to I2 and must be equal to I total. So which is equal to 12 ampere. Why? Because they are in series. Okay. So now, but if you look at this one now, IV said we should get the potential difference across each of them. The potential difference across each of them is the same thing. So we have that what? V is equal to what? IR. So what do I have? So V for 1 will now be equal to what? I1 R1, which is what? What is my I1? I1 is the same thing as 12. So 12 times my R1. My R1 is 2, which is what? 24 volts. So my V2 will be I2 R2, which is what? I2 is still 12 times my R2, 3. So what do I have? 3 times 2, 6, 36 volts. So if you see now, if you add 24 plus 36, it must give you the total one, 60. Is a must. Okay? So that is that for that. Hope I can clean. Question number 5. So now let's go to question number 6. You may be asked to draw it. If you are asked to draw this, we'll have this. They are in series. So you have your first resistor, 2 ohms, and then the second one, 3 ohms, connected to a battery. And the battery has 60 volts. So that is how to draw that. So the next question, question number 6. Question number 6 gave us something like this. And they say that here is 2 ohms. And that here is 3 ohms. And they gave us this one connected as 12 volts. Okay. So they now say calculate I, the total resistance. II, total current. III, current through each resistor. IV, potential difference through each resistor. Okay. Solution. Now, whenever something is arranged either in parallel or series, the first thing that should come to your mind is P to P. And what is P to P? P to P means that what? That the potential difference across a parallel circuit are the same. So, and this thing is parallel. So the potential difference there are the same. So let us get the total potential difference. So I have that what? For the one in parallel, I have that 1 over R. I want to get the total resistance, sorry. Okay. So which means since I have this, 12 here is the total one. So which means the potential difference across this is still 12. The potential difference across this one is still 12. Why? Because it's the same potential difference across them because they are in parallel. So let me get the total resistance, which is the first question they asked me. So for parallel, you have 1 over R is equal to what? 1 over R1 plus 1 over R2. Okay? So which is what? 1 over R total is equal to what? 1 over 2 plus 1 over 3. Okay? the fastest way to get it is by saying R total. You can find LCM, then later you turn. But the fastest way is just say 2 times 3 all over 2 plus 3. That is the fastest way. And we use this method for only when they are 2. If they are more than 2, you cannot use this method. This is for only when they are 2. But if they are more than 3, look at what you are supposed to do. 1 over R total is equal to the LCM of this and this is 6. 6 divided by this is 3. 3 times 2. 3 times 1 is 3. Plus 6 divided by this is 2. 2 times 1, 2. So I will now have that this one will turn up and this one will turn. In fact, 1 over R total is equal to 5 over 6. So what I need is R total. R total means this one turning upside down and this one will turn upside down to have what? This. So it's the same answer I got here, 6 over what? 5 ohms. Okay? So if you cannot remember this one, just use your normal LCM. Okay? So I've gotten the first question that the total resistance there is what? 6 over 5 ohms. Or you put it in decimal if you like. Now, I said I should get the total current. I know that V is equal to IR. So my I total is equal to what? My V total all over what? R total. So which is what? What is my V total? 12 divided by my R total is what? 6 over 5. So which is what? 12 times 5 over 6, which is what? 2 times 5, which is 10. 10 ampere. So 10 ampere is the total current that passes through them. So since we said that the potential difference are the same across them, it means that what? That the currents are not the same. If the potential difference are the same, then the current are not the same. So if I want to find the current of the first one, let me call this one I1 and then I2. Okay? So now, my I1 will now be what? V1 over R1. Okay? Which is what? What is my V1? Don't forget that, know that V1 must be equal to V2 and it must be equal to V3 and must be equal to what? Sorry, the V total. And what is my V total? My V total there is 12. They gave me that the V total is 12. And they are equal because they are in parallel. So I will now say that my V1 is what? 12 divided by my R1, 2, which is what? 6 what? Ampere. So for my I2 will now be what? V2 over R2, which is what? V2 is T12 divided by 3, which is what? 4 ampere. So if you add these two, you are still getting that the total current is what? 10 ampere. So that is that. The IV, they asked me, they say the potential difference across each of them. I will simply tell them that V1 must be equal to V2 and it must be equal to V total, which is what? 12 volts. So why? Because they are in parallel. Okay? It's a parallel arrangement. So question number what? Number 6. Question number 6, they gave me something like this and said that here is 5 ohms, then connected to 6 ohms and connected to 6 ohms, connected to 3 ohms, don't mind my own drawing, please. Okay, 30 volts. Okay, so they now say calculate I, the total resistance, II, total charge, III, current in each resistor, IV, potential difference in each resistor. Okay, so solution. For I, whenever you have a resistor connected, in fact, or anything at all that is connected in both series and parallel, please solve the parallel first before solving the series. So we need to solve the parallel. Once you solve the parallel, is already in series with this one, you now solve the series. Okay, so I'll say that what? 1 over what? R for parallel is what? 1 over 6 plus 1 over 3. So 1 over R parallel. Okay, sorry, I told that the easiest way to get it is to say R parallel will now be what? 6 times 3 all over 6 plus 3. 6 times 3. 3 times 6 is 18 all over what? 9, which is what? 2 ohms. All right. So now the R total now will now be what? 5 ohms plus what? My RP, which is what? 5 ohms plus 2 ohms, which is what? 7 ohms. So the total resistance there is what? 7 ohms. So the next thing we need to get is the total time. And I know that what? My V is equal to IR. V is equal to IR. So my I total will now be what? V total over R total, which is what? My V total there is 30 divided by 7. So if you can have your answer in point if you feel like 4.3 ampere. So that is my I total. So now, so to get your current in each of them, the current in each of them, okay, we can solve it using ratio. Yes, we can solve it using ratio. So the current that flows through this place is that the current that enters here is this 4.3, and the current that enters here is the same 4.3. So the current that passes through each of them is what? Is 4.3. So how do we get that now? In fact, the total current there is 4.3. So how do we get it? Okay, we can solve it in two ways. We can solve it by ratio. We can solve it by ratio. I will tell them that the current on this is the current. The current here is 4.3, and the current that passes through these two is the same 4.3. So we tell them that the current in the 5 ohms resistor is equal to 4.3 ampere. Okay, but the current in the two of them is the same 4.3. So I'm going to use ratio to solve for each of them. So I'll tell them that the current in the 6 ohms, I will use ratio. And what do I mean by ratio? I'll say that 6 all over the total. The total is what? 3 plus what? That's 6. Then times what I'm sharing, the total 4.3 that entered in the both of them. So what do we have now? 6 over 9 times 4.3. So what do you have? 6 over 9 times 4.3 will give you okay, let's calculate it now. That is 6 times 4.3 now divided by 9. So I have 2.86. That is approximately 2.9 ampere. Okay, so now the current that the current in the other one, which is what? In the 3 ohms, you can use the same ratio. That is that 3 divided by the total 3 plus 6, then times that 4.3. So what do you have? 3 over what? 9 times 4.3. So what do you have? So we have that is 3 times 9. So 3 times 4.3, then divided by 9. We have approximately 1.4 ampere. Okay, so 1.4 ampere. So now what do we do? So then I say we should calculate the potential difference across them. The potential difference across them, across the 5 ohms will now be what? You know that V is equal to IR. V is equal to IR, which is equal to what? That is I, the current that entered there. And the current that entered there was 4.3 times, 4.3. Then times R there is 5. So 4.3 times 5, 4.3 times 5. I have 21.5 volts. Okay, so the current that entered in this one, the potential difference across the 6 ohms should be what? V is equal to IR again. V is equal to IR, which is equal to what? My I there, the current that entered there is 2.9. 2.9 times the resistance there is 6. So 2.9 times 6, 2.9 times 6. So what do you have? 17.4. So for the last one, the potential difference across the last one now. The potential difference across the last one. The potential difference across the 3 ohms should not be. We know that V is equal to IR. So the current that entered there, we calculated it as I've cleaned it to 2.9, right? Sorry, 2.9 was the other one. 1.4. 1.4 times the resistor there is 3. So 1.4 times 3, 1.4 times 3. So I have 4.2 volts. Okay? So if you check it now, if you want to check it, you will now see that the first volts we got was what? 21.5 plus 17.4 plus 4.2. So add them, what do you have? 21.5 plus 17.4 plus 4.2. You have what? 21.5 plus 17.4 plus 4.2. I have 43.1. So what is the problem? Oh, sorry. So the problem here, that is why you need to check. The problem here is that the potential difference across the one in parallel are the same. Sorry, you should know that the potential difference across this one in parallel should be the same. Okay. So what do we have? How do we get the potential difference across this one in parallel? We have that. How do we get that? Okay, V is equal to IR. So I know that the potential difference across both of them are the same. So V is equal to IR. So which is what? My V there, my I is the current that entered there. And the current that entered there was 4.3. Yes, the same 4.3 entered in two of them. So 4.3 times the two of them, the two resistance are going to share it. So we have times the two resistance. And we need to get the total resistance of the two of them, which gave us 2. That is it. So it should be the what? In fact, sorry. So the potential difference that entered in the parallel should be what? The current of the parallel times what? The resistance of the parallel. So what do we have? The current in the parallel is there 4.3 that entered there times the resistor of the parallel gave us 2. So if you do that, you are going to get that it is 2 times 3 is 6, 2 times is 8. So this is volts. Okay, but they are two sharing it. So 2 of them will now be what? 8.6 volts. So each of them will now be each of the resistor will now be what? 8.6. 8.6 divided by 2, which is what? Which is 4.3 volts. So each of them is 4.3. So let us check it now. To check it, you will now have that. You now have what? 21.5 plus 4.3 plus another 4.3. So to have that what? We want to get the total voltage there. The total voltage there will give you 4.3 times 2, then plus 21.5. I have 30.1, so approximately 30 volts. This is very, very correct now. Okay, so the next one. So the next one here, they gave me something like this. Say this one is 4 ohms, and this one is 6 ohms. Okay, connected like this, connected to this one here. This one is 3 ohms, then connected to another one here. This one is 1 ohm, then connected this way. Current came in here and left here. Okay, so the next thing we should calculate What they say we should calculate there? Calculate the total resistance. We have to calculate the total resistance. Calculate the total resistance. Calculate the total resistance. Okay. So first of all, we need to arrange this one in parallel. So solve the one in parallel so that it will not be in series with these ones. So we have that word solution. For the one in parallel, I tell the 1 over P, 1 over R for parallel is equal to what? 1 over 4 plus 1 over 6. So P R for parallel will now be what? 4 times 6 divided by 4 plus 6. So 4 times 6 will give you 24 divided by 10, which is what? 2.4 ohms. So the R total will now be what? 2.4 plus 3 plus 1, which is what? 6.4 ohms. Okay, very simple. 6.4 ohms. Very, very simple to calculate. So let me check my time. Okay, so thank you very much for watching. In our next video, we'll talk about types of electric circuit. Bye bye. Please like, share, and subscribe.